Hey, hi all. I'm Vikram Shitole. I work as an senior prototyping architect at AWS. Been with Equal Experts for almost 9 years and then moved on to AWS, but still part of the Equal Experts network. So within Equal Experts, it's like once you are in, like they would keep you in the network so that we hear of all the great work which is being done. I've been active in over that side and been working on the generative AI where wanted to share it with the community, and that's why I'm here. So today we'll be talking more on stuffs which is like what is exactly generative AI, strategies around generative AI, use cases what currently are being solved using generative AI, and then a few quick demos which I have on my machines, which we can try it out, and then we can have our own Q&A. So we'll start with bit of an history, but before that, like everybody over here, I think aware of what generative AI is, been using the whole generative AI thing, but like anybody having more of like production, like taking any Gen AI workloads into production, any that type of experience over here? Okay, almost all. Okay, that's good. Uh, So I think then probably the session might not be like that great for you folks because it's just building blocks, but we'll probably try to see on the use cases and all those things where we could be doing it. So the journey started with like we started writing like the normal programs or chatbots where it was like very fixed inputs, fixed outputs, those type of things which came in. Then the first thing came in like in the 80s about uh, more of ML algorithms where we were doing like few tasks using machine learning. Thanks to the CPU advents and all those things, we are able to create more complex algorithms to solve more of the ML problems which were there. Certain. Then we moved on to the things like the cloud came in, then we had IBM Watson in between, then Siri came in where all the audio started coming in, going down, Cortana and Alexa both using audio inputs and audio outputs where so it is type of generative AI where we put in text and then the text goes out as an audio. Then we had the Google Assistant. So this was the story till 2017, and then after 2017, what we got is the great paper written by the Google folks. Attention, what you need, and that's where the transformers architecture came in, where it became more like we had all the different models like BERT and all those things, but with that transformers architecture, it became like it moving towards more conceptual use cases of summarization. All those things started looking more easier to be done with it. Then that's where like 2017 to 2022, it was more of research being done at OpenAI and all those things, and that's where to 2022 end of 2022 we got the first ChatGPT version which was there. That's November 2022, and that after that it was more of like we understood like where all it could be used, and that's where the first use cases of things started coming in where it could be like normal email writing things which were like too complex at like people used to spend like at least an hour to write those things, but with now I don't need to know the language that good, but I can just use this type of tools to convey my message in more of a sophisticated way. And then we got the newer models. Anthropic had their own, where Claude was there. Then Amazon had the Titan. Meta came with the Llama ones. OpenAI came with GPT-4. AI One-to-One Labs came with their Jurassic models. Mistral was also there, and there were a lot of them. Like I think with the last week or those type of things, we are not even talking about like the things which are being done, but then lot things came up with open source as well. The Quen model Hugging Face came in picture, where you could host your own models on it, and then deployed it onto your own CPUs and all those things. And that's where everybody started making it more of like a commodity, where you just don't have to host it, you can use it just by pay per use type of thing. So Google got their own Vertex AI, Amazon got something called as Bedrock, then Microsoft got something called as Model Garden, where everybody can host their own models, and then people can just use those type of ones. Uh, then we had the new techniques coming in. I think this slide is still old. In 2023, we just had RAG, which is retrieval augmented generation, which came in, where how you could use these tools to make it more contextual to data which is sensitive to you, and we'll be taking a bit deeper look when we go into that particular aspect. Uh, Financial services started fine tuning it, because these models were very specific. They were not having all the data or all the terms which a financial organization would use, or even things like if you're doing any insurance type of industry, then specific terms used by underwriters, those were not there. So all those type of things were done as part of the fine tuning, where the the regular foundational models, or the FMs, are then trained with labeled or unlabeled data depending on the use case, and then to get better results. Because whatever we've seen is like, if it is very generic use case like text summarization or all those things, the accuracy is quite good. But once it goes into a specific domain like insurance or finance or automobile or whatever, which needs more of deeper understanding, that's where the accuracy starts going low. So those were the things which people tried, and 2024 is the year of where we saw a lot of people productionizing it, where chatbots were coming, or AI chatbots were coming for almost every site. Then it moved on to a level where we also got like the um, mm, uh, OpenAI's real-time API, where it could take in audio and give out audio back. So even that level of automation came in, and we've seen systems which are almost there in production with those inputs, where people call directly, and OpenAI audio and input and output starts, and it is so flawless that we think we are talking to humans at the end. 2025 start, it just went berserk with DeepSeek coming in, and the cost going down. And I think that's something good for everyone, where we are probably using more. It's democratized, where people start using the smaller models. Earlier, it was like out of reach for a lot of them. I think you could have seen the interviews which were there. Like, if you need to have to even train the bigger models, it was like at least $1 million to push in terms of the GPU and the energy and all those requirements coming in. Stargate was like $500 billion. Yeah, so they invested all those things. Yeah. I don't know, planned or unplanned. Yeah. DeepSeek just. So those things are like, I think it, like, this field is evolving at a pace where I think probably 10 years back the JavaScript frameworks were evaluated. So I think every day, I think now they have stopped because AI has come now. So we had the blockchain phase some time back, now the AI phase. So that's where I think we are moving. But probably after a period of time, we will have some stability, where it would become more of like, okay, this is the way it would be. So what is generative AI? So I think everybody is aware of it, but just about talking it, it's there are couple of types which I'll put it like text summarization, where text goes in and I could get text out. There are image generation, where I could send in text and then I could get the image out. Or the newer ones are like, I could send in text and I could get the videos out. So there are new models like the DALI ones, or on Bedrock now we have something called as the Amazon Nova Reel. Then there's Luma AI. So those are the ones which take in text and you could get a video created. Not a very long videos, but like 5 to 6 seconds type of things which are coming out. Then there's other way around. It's like you get, yeah, sorry.
So is LLM only for text and other foundation models? I mean, is foundation model a wrap? I mean,
Foundation model is a wrapper.
everything,
Yeah,
both,
yeah.
and LLM is just text.
Yeah, large language model, but those are also having capabilities. Like we say, multimodal capabilities, where
Okay.
LLMs
So
can
what is
also.
difference between LLM and foundation model? Large language model versus foundation model.
Foundation models could be like they could do audio to audio, they
Right.
could do text to image,
Right.
whereas large language models, it could be primarily getting out a text. Like,
Okay.
okay, so it would be the return would be always a text. But
Oh.
foundational model, it could be
Yeah.
like the output could be an image, an audio,
Yeah.
or it could be.
But what is model? What is multi-model LLM then?
Yeah, yeah. So multimodal LLMs are like they could take in image and
Okay.
give you text. They could
Got it.
take video and give you text. So those are the multimodal type of foundation models.
Okay. Thank you.
Yeah. And then the other ones are like which could take like the multimodal ones, like they could take images and generate text. So the use cases which we had Prasad talking about, like the UI or the architecture diagram, which is it, that could go in as an image and we could get as and complete output of the JavaScript or those type of things as an output out of it. So those things could be, I think, with Cursor, if you have used Cursor, the tool, then it generally does, like if you have wireframes, it could convert it into text. Like you could get a React code out of it, and then you could probably start directly working on that. So, how different it is. So, first we had normal machine learning where it talked about uh, simple inputs, and we only had like simple output, whether it was more of predictive, like this were like the four parameters, and can you predict whether it is true or false, those type of things, very specific things. Then came in the complex things where I could send an image, and then with a pre-trained data, it would say, can you identify whether it is a cat or a dog or those type of things. So that's where the deep learning came in, where I could send a stack of images as unlabeled data, and then I'll ask, can you label it, and then I'll send labeled data, and then I'll ask whether, can you tell me whether it is a cat, or whether this image and this image, how much similar they are. Those type of things started with deep learning. Then came the foundation models, which like the input is complex, where it could be like a bunch of text, and the output is like, can you probably, I have a set of guidelines, and can you see whether this particular text which I have written is following those guidelines, or can you convert this into more of an grammatic way, or can you create a poem out of whatever I've just said. So those are the type of complex things which came with the foundation models. So I talked about text, but it could be about audios as well, or even videos as well. Like the recent ones, the Luma and the Nova Reel ones, you could put in like, can you generate a advertisement for a car with camera panning from top to down with a background of snow and all those things, and I could get a 6-second video out of it, where I could directly use it like a short video on my site to show that, okay, this is the type of advertisement. So though that's the complexity of the foundation models. And when I say the complexity, the amount of uh, 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 the compute needed for training this is high, as well as the amount of data set or the data needed to train this is also very high. So what generative AI does well for now? So summarization, and I think we do it like, can you summarize this email, or can you summarize this document? Content generation, be it text, image, audio, video, all those things are being done well right now. Language translation is being used a lot nowadays, where I've seen we have this call centers coming up, and if people asking queries in a different language, and the guy who is supporting earlier needed to be knowing that language, so that, but with this whole LLMs, everything, we are able to convert it into a specific language. like, can you tell me what's this particular thing in my language or whatever language you want? And it helps the guys to again reply back into their language, and then the conversion happens. So that type of use cases are also seen. Correction paraphrasing, this is something which is very commonly used by everybody, like not just like the product owners or business, but even us. Whenever we are writing emails, we just check for the grammar or those type of things when we are writing things. And now it is coming inbuilt where people are trying to put it within the Microsoft Word, where as Copilot, uh, when we are creating PPTs, or even if we are going to add it inside a VS Code, where can you check those things? So that's where the correction and paraphrasing will come in. And classification is more for putting in like different terms together, whether I think we have an example for like the few shot prompting ahead, but it's more of like, can you, these are my examples, and the next time if I send this word, can you classify whether it was positive or negative? Type of examples would be seen.
Was language translation always AI related?
Sorry.
Language translation.
Yeah.
Is language translation always and like from the starting was it an AI
Yeah, it
generative
was
AI?
like, we whatever we had were specific models which were doing it. Like if we used to say this model was only capable of doing from English to French, or this was only capable of doing French to English, like translate.google, whatever was there, there was like a model in the behind which was doing it, but it needed very small amount of compute and very small amount of training because they were specific. But when this bigger model came in, they are capable of, like, the amount of data set I give, they are capable, some are capable of doing like 200 languages. But like they you wouldn't see the same accuracy probably, and that's where the difference would come in. Like a model might do very good with English to like all the English dialects, like the French or German or Spanish, but it might not do really great with like our own language, the Indic languages, or Chinese, or where the dialect is very different than the English one. So at those times you will probably need specialized models. Yeah. So I think everybody would be aware of this, but we'll still be demystifying some of the GenAI terms. So vectors is something very important when we are going to do something like RAG or retrieval augmented generation. So we store all our textual data in form of vectors because as we know, machines are only capable of doing more of like the comparisons which are related to numbers. So what we do is we convert this text into vectors, and I think everybody of us, if we are computer science graduate, we would have done like the vectors as part of our maths thing. So I'll show you how those vectors look like. It's normal, like the 2 by 2 or 3 by 3, those type of vectors. Whenever we send a text, it converts it, and that's where we have models, or those are called as the embedding models, which convert your textual format into a vector format. That's the embeddings part. So embeddings is nothing but a collection of vectors. So whenever I say, hi, I am Vikram, and if I want to convert it into an embedding, it's nothing but a collection of vector which is stored as embedding. And these embeddings help us to do the retrieval. Parameters. So memory means the larger the number of parameters, the better it performs. So if you've seen, like, there are models which are 7B, 8B. So it's nothing but like 7 billion parameters or 8 billion parameters or 405 billion parameters. So that's the amount of data and the data set which has gone into it, and on those number of things it has been trained. So the more the number of parameters, the amount of compute needed to run is that high. So if you have like smaller 1B, 2B type of things, we can run it even on our normal machines. But if those like go above like 100 billion, then the amount of RAM and all those things needed is quite high. So we'll need like specialized boxes with GPUs, which would be there. This is something I think everybody would need to learn as we go ahead, like prompt engineering, because this is something we I think we use it daily, where we are probably asking ChatGPT to do some mails or all those things, and if we want to get a better output, we just add few keywords here and there, like think think like a professional writer, or think like a domain expert in insurance, or think like a domain expert anywhere else, or think like a seasoned developer. And then those type of lines actually change a lot, and that's what is prompt engineering. For a given output, the same model might perform differently even if you just add couple of words into the instructions which are going. RAG, we talked a bit about it. So it is retrieval augmented generation. And this is where the data is not with the model, but what we do is we give the paragraphs, like these are the paragraphs, and this is the question which is asked. Can you please create an answer out of this paragraph and give it back to me? So that is the retrieval augmented generation. This is a new thing which is coming in and quite lot used to improve responses and also to reason. And this is called as the agentic system, where we could provide the LLMs multiple tools and let the LLM decide the flow. So it could be based on like, okay, if I want to book a ticket, I could give an agent which is first capable of retrieving whether there are bookings available, and another agent which is basically looking at whether how to do the exact booking. So a booking agent and a retrieval agent, and let the LLM do the further parts, where it could say, okay, first do the checking of the system, it would call that particular tool, and then the next part, if the availability is there, it would go and book it, or it would respond back saying that there is no availability of tickets. And this could be going to a very complex level where people can everything could be done in a very different way, where we could have multiple agents and let the LLM drive those type of things. I think we'll certainly have softwares going that way, where earlier we had microservices, we would probably get agentic systems which would be replacing the microservices, and the orchestration is all done by the LLMs. Pre-training, this is when I create the complete foundation model from ground up. I know the data set and I know what needs to be done with it. That's where the pre-training comes in. Then there is something called as retraining. So I have the data, and probably something different over here is like I have the FM model and I give it as an unlabeled data, and then retrain this particular model to just change or add that additional data to improve the accuracy. And then there is fine tuning, which is labeled data, like this is the answer I expect, and this is the data which is there. So whenever you're going to give, so that's the difference between fine tuning and retraining. Retraining again, first pre-training needs the maximum amount of compute, whereas retraining would need lesser, and fine tuning would need more less in those terms. So that's how the things would go on. uh, so we talked about this one. The model you choose depends on the desired output, and what model I want to use would decide what is the input and what is the output which needs to go. And so when we talked about multimodality things, like summarize this article, it's more of like text generation. Take the textual input and then give out a summary, which is again a textual output. Uh, if And then the second part is like a photo of an astronaut. Can you generate it? And then we could use the image generation model like SDXL or the Amazon Titan generator, and it would generate the thing. A young couple walking in rain and all those things. So it is more of like a video, not video, but on audio generation, and video generation is separate, and then it could convert like the video separate, the audio separate, and all those things as a thing. And then depending on the use case, we could use the embedding models, where I want to store the data into the database, where we have something called as the vector database. So first we need to convert the text into vectors, and then we store it into the database for retrieval augmented generation. So that's where the embedding models could be used, and the output is like vectors. But these things are evolving fast. So even within summarization or even within like text to text conversion, we have like models which are faster. So the smaller the model, it is faster. The input and output time becomes low. But then the it is not able to do reasoning or those type of things. So if I want to write emails, I could probably do it. But if I want to do something like, okay, can you take this input and can you give me like these are a set of rules and can you give me a JSON output based on this particular thing? That's where we need a bigger model which is able to probably comprehend what needs to be done and also knows specialized formats which need to be done and then give the output back in those specialized formats. So we have even for code generation, like if I tell uh, chat gpt to write, okay, can you write code for like adding two numbers, and then it would be able to do it. But that's a very large model. We could probably get the same capabilities in a very small model if I just want to create like code creation models. So there are models from Qwen which are only for like code generation, or there are code llama models which are only for code generation. So their very specific task is for code generation. They might not do really great with like the summarizations and all those type of things, but they would write a really good code at a very fractional cost. So we need to keep this thing. I think we follow this thing when we are estimating our projects. Like if it is complex, then time and the efforts. So the same way we have this. So speed, latency is one side, accuracy and cost is another side. So smaller the model, lower the cost. Uh, you can basically, but the accuracy is uh, low, but the speed is very high. So if you have a model which is very small of doing specific things, you will get the output immediately. The cost of running it would be also low, but we might not get the same accuracy we might get from a bigger model. Large models like the GPT-4 or the Claude Sonnet, which are there, running that is like going to take a lot of your cost or the GPUs or the compute needed. Same way, but the speed would be also low. Like you would get the first token probably after like 5 seconds sometimes, or 3-4 seconds, though it depends on the use case. But like the accuracy would be the highest in those cases. So it's a trade-off which we need to look at. What is my use case, and how much the customer is ready to spend, and whether it does really make sense to use this model. And that's where with this tools like the Vertex AI, Code Llama, or even with Bedrock, we have that option of choosing the right model based on our use case. So we don't have to host that thing, and then we could use the smaller models for like this summarization things, but like the bigger models for more complex tasks. So strategies for implementation and their trade-offs. So the first one starts with prompt engineering, and this is the easiest way to get like accurate answers based on our input and output. So we could have like our input going as, okay, can you write an email, and then it could do it better. But then we could just add a single line of thing where, can you write an email and think as a professional English writer. It look at the output which would be there, and there is a vast difference, and that's where the prompt engineering thing would come. And every model actually has things, underlying things which are very different, where we have seen like if we give a context in XML tags, and we said to a model that this is the context which is in the XML tag, and can you try to summarize it, it does much better job instead of we sending it like text blobs at one by one. So uh, those are things which we need to understand, and that's where the prompt engineering thing will come, where I need to understand how the models work, how can I improve, where I need to think put it. Like in case of Claude, if I put the context at the top and the question at the bottom, it does a better job than doing it in the reverse way. So that's where the prompt engineering thing will come.
The reason is it's how it's trained.
Yeah, that's the how it is trained, and then how it would be able to put that loads and then do the further generation. So all these models are they are always probabilistic. It is not going to give you the same result every time you ask. It might change, and it's based on weights and whatever time or whatever loads and all those type of things. We will not get the same result even if we ask the same question, and it might differ. and there are parameters which we can put like top p, top k, which basically decide on like how much probabilistic things I can do, or how much the model can vary when it can give back the results. So those are the things which we need to keep in mind when we are doing all those things. I think we talked about RAG, where text generation is based on a specific corpus. So first thing happens is you ask a question like, can you tell me about employee policies at Equal Experts? So the first thing I need to do as an engineer is to first get what all are the policies of Equal Experts, convert them into embeddings and store it into a DB. When I ask you a question, the first thing it goes and says, okay, can you search if there are contexts related to policies? It would give me like a bunch of text, and then I would use that and generate it saying that, okay, these are the policies of Equal Experts which you need to look. When we talk about agentic system, where understand the task, and depending on the tool which is being given to you, call those tools automatically. Fine tuning, give model, company or domain specific data, and ask any foundational model to basically train on top of it, or to get the output on top of it. And retraining is like everything goes back into the model and with the additional data and everything, and then we retrain it to get the best output. So those are the trade-offs. But if you see from bottom, the accuracy improves, but also the complexity or the cost increases. So prompt engineering probably by far is the easiest way to improve accuracy, but probably you wouldn't get the highest accuracy which you might get with retraining or fine tuning.
Can you quantify the accuracy jump from RAG to fine tuning?
Uh,
Like rough estimate.
haven't done anything, like I don't have anything right now, but I'll probably try to find out if we had any study of exactly like how much was the difference. But what we've seen is like uh, uh, company or domain specific data. That's where we have specialized domains like healthcare, insurance, or FSI. That's where specific terms are not used, and then that's where the fine tuning part comes in. Where the vocabulary or the exact keywords used, those are different, but I don't have the exact data in terms of the jump how much it is, because this is the RAG part is going to be very specific on the number of tokens you are going to get out of it. So you wouldn't be able to say that for this question, the question might be only gone in like 3 chunks, and we will be able to answer in 3 chunks. But if the question is going over like 100 or 200 chunks, then the RAG wouldn't even work, because there is a limitation on how much I can send, because the context length and all those type of things. So those things probably with fine tuning or even with retraining, I would be able to hit that thing.
I have one very nice question,
Sure.
Vikram. Are these strategies used in combination to solve a specific problem by
Yeah.
a model, or you have to choose a strategy and stick to it?
No, it's always like start with this, then this, uh, and that's
So a
how it
single
goes.
model can have all the strategies and decide which one to use which.
Based on the use case. So that other diagram which we saw, where cost and slowness and all those things. So if the model is slow and able to give me accuracy, but it is slow and it will be costly, what I'll do is I'll get a smaller model. I'll use my own data. I'll retrain it and do. It's not the same model, but the trade-offs are different. It's not going to be the same model with retraining or the same model with fine tuning. It could be like I used a bigger model for the prompt engineering and the RAG. I was not getting the results. I probably tried, okay, if I can just fine tune a smaller model with my specific data, would I be able to get? The things where I need to there are other things which also change a lot with this is when I do fine tuning, I give a specific data, but in case of RAG, my data can change over time as well. I can just dump my DB and say, okay, this is the newer data, and I don't need to change anything in my model or anything. It would just retrieve the newer context and try answering those questions. But if I'm going to have my data changing, then fine tuning, retraining probably wouldn't even work, because that's a very high cost thing which I need to do every time if my data is going to change. So those are not like this would work over other, but it would be more use case driven. Uh, so this is a few examples of prompt engineering. Uh, so the input is like finish the sentence in futures cars can fly, and then the output cars can fly because they have wings, and so that's the model returned back. Then we have zero shot learning uh, where I say I like this movie. This review is it would just say positive or negative based on whatever how it is able to quantify. But if I do few shot, I give it examples where this is the first example, this is the expected output, this is the second example, this is the expected output, and that's where the few shot learning comes in, where I tell the model that understand this context, and when you are answering, use that above context and then answer. So that's where the different, there are multiple actually, I have just covered two, but there are more than this different types of, but most of us use only one of these two, but as we move towards advanced use cases, we use the other ones as well.
So zero shot
Sorry.
and open-ended are different. Closed-ended prompting. So there is closed-ended prompting. For example, is Paris capital of France?
Yeah.
Right? Yes or no?
Correct.
And then you have provided zero shot learning.
Yeah, so those are like examples which I've given. Like this, when this type of input is there, this is the output I expect.
Actually, I'm not able to read it.
Sorry. Okay.
The color is
I
maybe
think
on
so.
laptop it's more
I
visible.
think it on
Review.
my laptop
I liked this review. This review is.
then the output is, can you tell me what type of review it is, whether
Oh,
positive or
okay.
negative? And then I give it examples. I love this movie. The review is positive. The movie was waste of time and money. This review is negative. And then I think I like this movie. Then can you tell me whether it is positive or negative? This is one type of thing, but like these are the ways where I could say, okay, this is my input which is there.
Yeah, got it.
And then can you give me as a JSON as an output? That could be your example to the
Okay. Yeah.
LLM.
Yeah, I'm understanding now. Thanks.
And then this is the RAG, where the first thing is about converting the documents, and probably if you're not an Amazon user or an AWS user, it could be not straightforward to you. But when I say Amazon S3, it's a way of storing blogs and everything. And I get my documents in an S3 bucket. I process them using embedding models, and I store them into Amazon OpenSearch, which is in vector DB. Your vector DB could be anything. It could be like in-memory vector DB, or it could be Aurora or Postgres, depending on whatever is your choice of things. And what vector DBs do is like they help into the cosine similarity or Euclidean distance. So those are the type of ways to find out which is for this particular question, which are the closest paragraphs I need to pick up. So the end users would talk to the web application, or in this case it would be Amazon API Gateway and the Lambda. The first thing it does is like, can you, for my question, give me the this embedding. It would return back the embedding. The next thing would be use that embedding, make a vector search to OpenSearch, that is number 5, return back me all the context in plain English language, and I use those things to call a Bedrock text model based on whatever is the prompt which I have written, whether it is to summarize the question or to answer something. Based on that, it would return it back. It will give it back to the Lambda, and then it goes back to the user. So the same thing what we generally do when we do ChatGPT is like, okay, can you write an email, and it goes and does it, but it doesn't do a vector search. But in case of your thing, like I think everybody would have some AI based application in the offices where can you tell me which Confluence page this particular architecture is there, and the Confluence pages are actually first we create embeddings for those things in the background, and then it goes and searches the embedding thing, it gets the text output, and then at the end it would give you the URL. So that's the type of thing the RAG does in a different way. Agentic systems do this for me, and then when we create agent, you say that you are an agent and you are capable of doing this actions on this knowledge base, and then they do it, and it could be anything. So like if you go and ask, probably I think, I don't know whether they fixed it or not, but like if you can go and ask on ChatGPT what is the current weather in Pune, then it won't be able to answer because it doesn't have the current data. So in that case, I could probably create an weather agent and say that anything which is related to weather, first go and find out which city it is. Then it gives the city to the agent, and then we make an API call to the weather.com site or any other thing, which returns me what's the current temperature in Pune or the weather recommendation. And then I summarize that thing and return it back.
I have one question.
Sure.
RAG.
Yeah.
So in the previous slide, so let's say I'm feeding two documents here, right? And for example, scenario is equal experts HR policy.
Right.
I feed the first document, which is about all employees working from home and what the policy is.
Right.
And the second document is a few months later, it's the contradictory one, exact opposite. Why every employee should start coming into the office. Now, when I'm asking a question, what as a new employee,
Right.
what's the policies?
Right.
Is the answer going to be based on which is the most recent?
No,
Because there are
unless,
contradictory.
yeah. So unless you implement that, it won't be the answer. So that's where when we are making this search to open search, we'll need to add some like metadata fields, which are like when was this created, and metadata fields are very important, where you're going to have similar policies, but for different department the policies are different. So if you, as a department, you are from finance and you are asking a question, but from HR I am asking a question, there should be different documents selected. So that's where the metadata comes in picture. So like Aurora and all those guys, they allow to do more of SQL searches on top of it. Like I can pass the department as well when I'm doing the vector search. So I do like filter it based on that. So in case of the dates, we'll need to do like whenever I get the things, I'll need to say that only take top three, first sort it by date and take the top three ones, and then I send that as a context. So that
That's
part,
past is
yeah.
context.
So yeah. So then when you're doing that search, either you do it as a filter on that search itself, and that logic we'll need to implement. The vector DB won't be able to understand that. So that particular thing, as a programmer, I'll need to write saying that whenever you are getting any context from the vector DB, first order it by the date, use the latest ones first, and then I say only give me top three. Or the other thing is like I could mark those documents at absolute, or whenever I recreate those things, then what we have seen is like we generally delete those things when we are recreating it, if the same policy or all those type of things are coming, because then only you are going to get better results. Otherwise, we are not sure whether you will get an older document passage and a newer document passage. Those things as a developer will need to write it. The OpenSearch or the vector DBs are not able to understand what exactly you want. It would just give you an Euclidean distance and send it back.
Good.
Yeah.
Yeah, I have these doubts on like agentic AIs.
Yeah.
Suppose I have a I have to build an agent, and that agent needs to analyze some particular data and give the response. So how can we reduce the head weight? Suppose if I want to like make an API call and that gives like thousands of JSON data, like how can we reduce the head weight so that it can understand easily understand and give the like proper
Okay.
responses?
So, so your agent is calling an API which is
Yeah.
giving huge data.
Yeah.
And then based on that, you need to
Yeah.
the AI system. So we can do it in two ways. First is either let the AI do it, but I think AI is not that great with terms of like any tabular or those type of data. So I think we'll need to apply some algorithms on top of it to give it more refined things out of it, because it can do it, but then it could go in multi-shot type of thing as well. Like the first, yeah, I think he's here.
So it also depends on the model what you select. So if you have something like Gemini, which has a bigger context window, right? So in that case, also a bigger size of the response what you get from the API that you can feed it. So
Yeah.
Gemini has always been famous for these kind of use cases where your token size are pretty huge, like it goes in billions. So for example, if you have a source code of a code, you can give it to. So yeah, if you have a source code of your code, right? If you give it to Gemini versus let's say if you take to Sonnet or any other model, right? Gemini will have faster read and everything because its context window is big. So in your case also that can be one thing which you can try out.
Yeah.
Yeah, like I recently made a fun project, like a to-do app, where I have integrated a chatbot. Like you can ask the chatbot that, "Hey, what's the status of this thing?" So someone suggested me to like reduce the head weight, because when I click on, like when I ask it like, what how many to-dos are there, it's like calling an API and it's giving all the to-do number of to-dos are there.
Yeah. The thing is, like there are multiple strategies on how do we do it. Uh, First of all, it's like whenever it is going to take longer time, it is going to take time. The only way we could improve on that is to improve the user experience. So the way like ChatGPT does it, it sends the first token out as in, okay, this is the first response I've, and then as a human we think, okay, it's at least working. Instead, if it would have taken like, it is not giving out for like 10 seconds, then we would have gone and switched to something else. So those are the type of things we'll need to employ, where even audio cases, if you've seen, yeah, you make a call to an audio assistant, uh, actually there is a lag in between, but what they do is they put in filler words where it is like, okay sir, I'll check and answer your question. So those are the type of mechanisms as an user, or the way we build our UX would come in. And when I say, you need to remember that three triangle. If you want it to be fast, then the cost would go high, and those type of things we'll need to keep in mind when we are designing our end-to-end things with anything which is related to GenAI, where we could have this type of fillers or those type of changes which could be done, and we could get the similar experience for end users. I think we talked about fine tuning, and I think I'm low on time. I've just been told. So, uh, so yeah, sorry. So I send in examples of input and output, and this is labeled data. When I do fine tuning, I give the prompt and I do the completion. This is where reinforced learning or those type of things come in, where you could ask users whether the last answer given was good or bad, and that data could be used as a label, like this answer was good, this was the question, this was the answer, and the user said that this data, this is the correct answer, and those data set, then I can use it further to do the fine tuning. Yeah, and then retraining is like, I have a foundation model, but it didn't have my data. I gave it all my data without label, let it go berserk on everything, and then do it. Then I can make tuning with the PEF, LoRa, and QLoRa. Those are more of like the ML concepts. Like the plain ML still stays the same when I'm doing anything with fine tuning or retraining. As GenAI, it is more of like, I just need to know prompts and I will be able to do. But if I want to improve on the accuracy, then all these things need to be considered. This is the generative AI stack on Amazon, and I think it would be same on any other cloud provider, where we need the infrastructure. So we have SageMaker, Trainium, Inferentia. These are the chips which Amazon provide, or the GPUs, and anything which is related to EC2 blocks, everything. Then the second is Amazon Bedrock, which is like a wrapper around all the foundation models, and then a set of services with it, where we have guardrails, which is a very important feature, where I don't want my bots or my responses to go out of a specific domain. Like if I am a chatbot which is only related to travel, and if you ask me any health related advice, that's where the guardrails should say that, okay, I am just a chatbot which can talk about health, sorry, on travel and not related to health. That's where guardrails and all the enterprises, finances, and all those things. It's it's a must-have feature, because I don't want to get into lawsuits or those type of things where people can say that your AI is suggesting all those type of things. And then the agents, so there's specific agents which are coming in, and this is good when I'm going to call any AWS service within as well. If I want to call a Lambda, or if I want to make a database calls, and that's where the agentic systems and the agents would come. Studio is like I can create my own application, like a whole chatbot application using the Studio. And then the other part is customization and custom model imports. So those, like if you have created your fine tuned model, or if you want to do any customizations, you could use that with it. And then our own Amazon models, the Nova, the Titan image generator, and all those things. Then we have applications which leverage these FMs and all. So we have something called as Amazon Q, and there are like 3-4 different flavors of it. One is Q for business, where you could create your own RAG implementations with your own data, and you could create like an end-to-end thing out of your data with just few clicks. So you can select what embedding models you want to use, what vector DB you want to use, and that's where the Q for business works good. I think there's Amazon Q for developer, which is the coding assistant which you can use. So it integrates well with VS Code. And then if you can say, can you explain me this code, or you could just comment in, and it works only, I think, with Python and Java right now. The support for .NET and all those things are coming in later. Then we have something called Amazon Q for QuickSight, which is more for if you want to create dashboards where I have the data, and I could say, can you give me the trend of people who are attending the expert talks in last 10 minutes. So what it does, it finds out what are the fields I need to add, what is the customer, or what is the type of diagram or graph I need to show, and it would show inside that. And then there's Amazon Q for Connect, which is more for Connect is the tool used by all the agents and all those things. So it is more for like when I'm doing my calls, I could do live call analytics where it could go and make calls to the backend system and give as an input for me as an agent to answer questions and all those things. And then the App Studio is to create apps, whatever you want. We'll talk about a bit on the use cases, and these are the use cases where I think we would have used chatbot, virtual assistants a lot, conversation, then analytics and personalization, where I could personalize my content based on my use cases. I give these are the files which are there, and it could just suggest the different movies and based on my genre and all those things. Boost employee productivity and creativity. I think conversational search, when I say it, is more on like I think Teams now we could summarize the meeting notes and all those. So there are different type of tools which are there, and that's where the conversational search, I think, summarization. Content creation is like where I could say that, can you generate an image for my site, and then that's where the content creation. Code generation, I think we have seen all those things. And data to insights is the Amazon Q for QuickSight, where I have the data, and can you create me like a good dashboard thing where it could tell me how much was my sales in last month, and then it could just summarize it in a more proper way. Business processes, I think that's something which everybody is doing it. Document processing, where I could process my documents over a period of time, and then I could say, can you exactly extract name, gender, and those type of things. Or even if you are an insurance provider, and as an underwriter, if you upload the health reports, it could just scan through all those things, and if I ask whether he was a smoker or not, based on the the context, it would be able to answer those type of things. Same goes for process of optimization. Fraud detections, we have used it more for like name type of things, where there are few or specific type of names which are always there in fraud. So emails and all those type of things. So we use that in the fraud detection type of scenarios. So at a high level, those are the different use cases which we see into generative AI. And I think that's all which I had, but I don't know how we are on time. I had few things to show. So this is an open source version. You could find it on GitHub. It's like quite popular or than Amazon, but like the complete chatbot you could get out of it. And when I talk about RAG, this actually implements RAG. So the first part is like you get workspaces, and over here like I could add documents and all, where it could basically process those documents and create embeddings out of it.
Which language
Uh,
are these examples in?
uh,
Like, is it Python or?
this is all Python.
So
This is all
over here
Python.
it is.
Yeah, all Python.
Can we link it to like S3 and
Yeah, this is actually this is getting stored in S3 only. You could even do the automated version of it, where I could like here it uploads files, but like when I choose it actually goes into S3 and puts
and
into
then
S3 and then works out that way. I could do I can also ask it to do website and all those type of things. Uh, then this is workspaces, and I need to tell when I create a workspace, I need to tell what is the embedding model which you need to use. As Bedrock, we have a choice of embedding model and which could be used, and also the language the documents would be. Like when I'm going to do different languages, the I need to use different embedding model, which is capable of doing those languages as well. And then embeddings is something I'll just try to show. This is a text embedding model. I'll just show you load sample data. So this is the text, dog chases the ball and canine runs, and I'll generate it. It actually shows a really good thing. So it shows like cosine similarity and Euclidean distance. So mostly people use cosine similarity because the context is quite different, and in case of when the context is going to be too different, then cosine works better than Euclidean similarities. So for the first it is similar. For the second it is more closer because it is like a canine runs after a spherical ball. So a canine is nothing but like it is similar to a dog. So that's where the similarity search is more similar to the first statement. So that's how the vector search works. So when I ask a question about employee handbook, it would go and search for questions which are related to the employee handbook and then get out context.
What is number 5?
Number 5 is a vehicle is stationary.
Okay.
So it is not at all related. So you'll
Yeah,
see
yeah.
like
So 4, 5 are related, but everything else is different.
correct, correct. So fourth is an automobile is parked in garage. So 4, 5. So that's where the similarity is. Yeah.
is it like picks
Can,
up the
can you go down?
keywords and then does
Yeah, that's how the vectors work. So when we convert this thing, it converts it into an embedding. I am not sure whether I could. I think there was earlier we used to see that particular part, but yeah, this is the embeddings vector. So this is how in the background for the first input, this is how it would look when it gets stored into the database. So those are nothing but like actual vectors being stored into the database.
Nice.
So these are different, but that's where the vector search works. So this is more of low level, but like more of to keep the concepts like how embeddings and everything work. And then we have playground, and that's where we could use any of the models which are available. So these are the different models which are available on Bedrock: the Meta ones, the Mistral ones, the Cohere. Then from Anthropic we have the Sonnet, and this is like depending on the size of things, we'll have different things. So if I do it without a workspace, I could ask questions like uh, write Java code to add two numbers, and then it should be able to.
32.
So this is the technique which I was talking. Like you need to show the first thing, not the end output, and then so it is able to do like show it like how to do it. If I ask the same question to Claude 3 Sonnet, So it does in a different way. So though that's the model's capability. The bigger models do more descriptive and they would give out more data and all those things. I had actually done earlier one where I had also generated sessions. So this was the video generation. So this is the video which it had created. So it had like equal experts at the bottom, and so those are the type of things we could get out of the real models. So after this, there was one more use case which I was talking, and this was more of the conversational one, where I have an audio, and first I do is transcribe this audio, and the audio is where is it? This is the audio.
It's like English, like 7982, which is nice. 7982 double five.
So, so the thing is like the first thing we convert the audio into text. Once it is text, then it's normal LLM again. And as part of that, what all things you can do over here is like uh, you could have a set of rules, and this was more for like if I want to train my agents and look at their score, then it's like overall score. Has the agent greeted or not greeted? How was the communication? Did he add for feedback? And those type of things I could use to rate the calls, or to say that what is the action which I need to take as an email response. So it could be a good input for the agent to send an email back to the things. So those are the different use cases what we generally seen, and apart from that, I think that's what I had to show. If you have any questions, anything, then we can. Yeah.
Yeah. It's very interesting use case.
Yeah.
So the rubric on the right side, right? Did you provide it that QA like forbidden words, then CSAT?
Yeah, the rubric we provided.
Okay.
That this is the list of, and that has been provided as a JSON. That this is the first rule, this is the second rule, and then can you identify for this?
Is this
rule?
also open source?
No, this is not. This actually we, but yeah, there is a version of this as an open
On that
source.
GitHub, okay.
Same GitHub samples, you would find that as a
Okay, AWS samples.
conversational. So under this, you would find that as well.
Okay, multi-model, both audio,
Yeah.
etc.
Yeah, yeah.
Okay, that's awesome.
The reasoning models are getting popular, right? So how does this affect the whole flow, going from RAG to, let's say, fine tuning and pre-training? Now, when you introduce reasoning into it, for example, you generated that video for equal experts.
Correct. Yeah.
For let's say there is a O1 model which actually can explain why it did what it did. Does that exist for audio and video also? And also,
No. So for audio and all, Amazon currently doesn't have any audio model. It has a poly thing, but it's not like we have for the OpenAI, where it's I think the O3 Mini works as a real time thing. It takes an audio and immediately gives audio. But over there, it doesn't do the reasoning, but it sends you events as such. Like we haven't seen reasoning happening yet on the video generation thing yet with any of the models. Or at least I haven't seen. It could be there, but the only thing which I've seen with the audio part is the it sends us events like I have started this, or the customer, or they need to implement something called as VAD, which is more of like they need to identify when I stopped speaking, because it could go on, like it could wait till endlessly. So that's where they send in events, but there's no reasoning I've seen yet coming in for at least the audio and the video ones.
What is full form of VAD?
I think it's virtual. Sorry, it's more of voice. Yeah, I'll probably. Yeah, this is the
Voice
one.
activity detection.
Yeah.
Nice.
So this was the VAD. So there's a server side one, which is inbuilt in the OpenAI world. But if you are going to do it from the client, then this is the library which we used.
So was reasoning always there, but now they're exposing it to the end users, or is the whole learning architecture
one?
entirely different?
Sorry.
No, regarding the reasoning, was it always there? It's just now that the exposing it to the end
Yeah,
user.
it was always there because that's how the steps changes.
Right.
It was always there, but now it is more of coming as a structure thing, and we'll see that for the audio as well. It came as like how like events, but I think the next steps would be about reasoning that what it did and how it is going to do. But it is all basically the model providers would need to give it, and not like we as like an external thing, we can only consume it. We don't have the capability. It could be some flag which we'll need to enable, and then it would start reasoning those things.
Let's say there is a production an application, using one of those, right? But then now we want to use a reasoning model there. Do you have to significantly change what you used to do, or it's just a swapping the model for a new one?
It depends on if you are going to use that
Feedback or not?
like if you're going to feedback and use that feedback, as in if it is one shot, nothing changes. But if it is multi-shot, if you're going to ask me questions and then I'm going to go back, then that's where it would change.
Makes sense. Thanks.
I think that's all I have, folks. Any questions, anything we can discuss whenever we want. I hope you liked the session, and thanks for coming on a Saturday to attend.
Folks are interested, and I can show you a little bit the two talks how to integrate into your.
Yeah, there's one more demo. Actually, I'm not able to run it, but like this was my own demo, and no. Okay, so sorry. And this is like we had built it like you could draw your wireframes, and then it converts like a complete React app with one shot. So the React app sorry. So this is like there's nothing, but then once I say generate, hope my parameters are there. So then the background it should. So then it creates like the complete end-to-end flow of this into React, more of a code generation use case. I think what for you it would be, you're doing that as well, where an architecture would get converted into like an ISE script. And but yeah, I think
No, I think this is also good. Like, I actually wanted to show the other way around. How
Okay.
you can actually use the. So what I want to show is that how you can actually use AI, these kind of.
Okay, I think it is.
And all those things in your day-to-day.
Shouldn't take this much time.
Maybe after this, I can just.
No, I think you check it because I think yeah, okay, it generated. So if you see here, the thing had like a name, email, login. Then the name, email, login came in.
Wow.
So this is the multimodal capabilities where I could send in an image. Okay, that didn't work. So the next one didn't work, but it got the orders flow.
Yeah.
but one the next time. But this is like, this was my demo where you could draw a wireframe and then convert it into.
So it is writing backend code in
Yeah, yeah.
Node.js
So
and
like,
front end in
yeah, this is
Automate.
where I think
Okay, okay.
where
Nice.
it could have generated the code, but there might be some
Yeah,
error.
that's fine.
Mod issues.
Yeah,
This actually shows the
yeah. This is the problem.
Which service you are using?
Probabilistic, right? So anyway,
Uh,
Like which service you are using?
this is Bedrock. Like, we just using Claude 3 Sonnet, just uploading the image with a prompt saying that this is the image and can you convert it.
yeah, I think even Cursor uses
So
Claude Sonnet,
this,
and
yeah,
now
yes.
GitHub Copilot, which is provided to us, you can change provider. So sometimes for diagramming, I use Chat GPTs, and for documentation, but for actual code, I use Claude. So
Yeah,
which is
if
really
you,
good.
yeah,
You
if
have to
you,
experiment a lot. I mean,
yeah, if you have access directly for Claude and you are not worried about cost, then there is a tool called as Cline, CLI.
Offline, yeah, it's
So
free.
yeah, it's open source,
Yeah.
and then you
Open
could
source
use
actually,
that.